And then next topic I'm going to go, not topic, this under this topic, the subtopic. Having studied about this probability or the area we calculated, now we're going to go the opposite. If the area is given, what is the value, the random value? Again, I said at the beginning of the class, this is the continuous data. So we can take any value. Next one is inverse normal distribution. So yeah, we have gone through normal distribution, how to calculate. So in other words, how to calculate the probability. But this one, inverse distribution, is the probability is given, and then see the random value, what the value would be. If the probability is, say, 10%, what the value would be, the random value. This is what, so if you have that, again, same. You always, as soon as you normal distribution, this is what you have to think about, nothing more than that. As a bell shape, a symmetrical curve, which is mu, and the area under the curve is 1. That's always, those three always applicable to normal distribution. I said I wanted to find this value, I don't know, x1, they ask you to find what the value would be if the area or if the probability is less than this. So how will they do it? As I said before, x less than x1. This is x1 is the fixed value. X is the variable wherever from 0 to wherever. Equal is given 10%. 10% means this one 10%. 10% means 0.01. 0.01. So this is what they are given. It's a question. They ask you to find what is x1 is. Of course, it's calculate again. But this time, you have to select different option. The normal distribution, of course, and then you select option 3, which is inverse normal. Right. What is in here, when you go into inverse normal, there are 3 things the calculator asks you. One is the area. The area means this section. Area is set, this 0.01 area. The next one is asked, what is standard deviation? We started with the same example. Standard deviation is 10, so you can write it like that. X correspond n 50 10 squared. It's always write that. That actually gives you the full picture of what you are dealing with. This is the normal distribution, mu is 50, and the standard deviation. So it gives you almost everything what you need to know. And the question is, what is it if the area is 10% or 0.01, what the value is x? Again, calculator. The area is 0.01, and the standard deviation 10, and mu is 50, and value is 26.73. So x1 equals 26.73. So it has a value 26.73. This value is 26.73. As I said, I'm purely concentrating on guiding you to exam type of questions. So we have not gone through the calculation, the basic calculation, not up to the exam standard yet. The basic calculation of normal distribution. Then we are going backwards or inverse the calculation. So how to actually find the random value or the continuous value. Having done that, sometime this is pretty easy to do it. So if they ask you, say, is a 10 of 40 and less than or equal x2. So what it is, they give you the lower value, but upper value, they need to find the upper value. So this is, say, if this second, for this one, say this is 40, and this is, we don't know what x2, they have given the area between 40 and x2, which is, say, I don't know, say 0.70, 0.70%. Then you have to calculate the inverse normal in order to find x2. There are two things. One is the low value, but we don't know the upper value. So when you use the formula, the first option, option 2, to calculate normal distribution, we can't do it. But when you come to inverse, still we can't do it because of the way which this has been created. We cannot find x2. So we need to split that into two different formats in order to find x2. Let me go through that. Again, normal distribution, without thinking anything, you can draw this. Again, 50 as well, because of I'm just using the same example, so 50. And again, you write this x, this is x, correspond normal distribution, 50, 10 squared. So I'm using the same example in order to explain the different stage of the questions. We talked about this is 40, and this is x2. We have been given that area is 70%. 70%. They ask you to find the area is given between 40 and x2 is 70%. What is x2? As I said, it is when you use the calculator, we need to know the value of x2 in order to use the calculator. So see how we can go this way. The area, the whole of area is 1. Can I actually say that this bit is 1 minus the whole area? Am I putting it in a right way? Can you understand that? Instead of finding the whole of this area, that is, say for example, 40. So P, probability, x, less than 40, that is this bit, the left-hand side of 40. But we can write this as equal 1 minus the whole of right-hand side. Easy, isn't it? So say 3, you write 10 minus 7 as well. 3 equal 10 minus 7. We can write that so that we know the whole area is 1. This area is less than that. So I'm going to write it 1 minus the other area. So 1 minus P x greater than equal or 40. You don't write equal because of this continuous data. You do not think of equal or less. It's less and less than equal, both the same. So what it is, simply, if you could put it in a simple form, 3, I can write 3 equal 10 minus 7. Same, isn't it? So that is exactly what I'm writing. In order to find 40 less than, the x less than 40, this side, left-hand side of it, but that can be written, the whole thing is 1, with 1, minus something, the right-hand side. So in order to find the left-hand side, 1 minus right-hand side. Or in order to find the right-hand side, 1 minus left-hand side. Simple as that. So 3 equal 10 minus 7. Or 7 equal 10 minus 3. So when you go back to the question we ask, this is what they ask you to find. Less than 40, x less than or equal x2, that is given 0.7. That is given 0.7. We can actually split that into that, the whole thing left-hand side, the whole thing this. So if I could, rather than writing this is the upper value and the lower value, I could write this is the upper value, lower value is 0, and then upper value, lower value is 0. If I could subtract from the big one to small one, I end up with this. So I can write that P 40 less than or equal x less than x2 equal, I can write it, P x less than or equal x2, that is this side of the whole thing. But I don't want that, I want this bit. So if I could write the whole thing and then take away this bit, then I end up with this. That is minus P x less than or equal 40. Now, this sort of a combined format, or just split into the two different formats. This one, very easy to use that calculator because we know that's 40, we can calculate that, so we can find that. But this is what we have to find, x2. So if I go into write that, before I do that, let me find out what this is. So for that, the normal distribution, so select the normal distribution and select option 2, not the inverse, because I just wanted to find this. So normal distribution, that is option 2. Lower value, this side, lower value, as I said, always you take it as 0. So it's 0, the low value is 0. The upper value, yes, we know that in this side, so this is the highest value which we have to calculate with. So upper value is 40. Again, standard deviation is 10, and the mu is 50, and the value is that one, this value come up as, in a calculator, 0.16. 0.16, not percentage. That is equal 16%. 0.16 mean 16%. Simple as that, isn't it? 1 is 100%, 50 is 0.5, and then 0.16 is multiply by 100, give you 16%. So the whole thing, we have given this area is 70, but we don't know this value. That's a value to find, because I'm sort of heading towards almost closer to the exam type of question. So x2 to find, and this is 40. So with that format, we can't find it. With the inverse, we can't use it. So we need to split it. How we split it, this side, and take away this, gives you the middle part. We split that. This is easy to calculate. Having done that, so this is now, if I could take that, P x, then x2 is minus 0.16, which is, we have found it, 0.16, altogether equal 0.70, isn't it? Because of, that's the area. So now I have P x less than equal x2 equal 0.7 minus 0.7 minus 0.16. That is equal 0.54, yeah? Or 54%, right? This bit is 54%. Easily, without going into too much, that's 54%, this side. So if we can see where this is right, this, no, plus, sorry. This is what, yeah, sorry. Right, okay, let me put you in the right mind. So I just end up with a 54% because I made a mistake. I end up with a 54%. But straight away you should know that's wrong because of this bit is 70%. How come this side of the whole bit is 54%? Of course wrong. So I made a mistake. If I take this to the other side, it should be plus, right? So that will be 80.86. or in other words, 86%. Yeah? And now I'll just see whether I'm right. Because of this bit is 70%, of course, the whole thing is 86%. This bit 16%, 76, 70%, 86%. Right, now I got this 0.86 for this. So this one is x less than x2 equal 0.86. Right, now we know the area. We need to find this value. So what we have to do, we have to go back to the selection of inverse. So normal distribution, option 3 for inverse. Right, area. Area is 0.86, sorry, 0.86. The standard deviation is 10, mu is 50, and the value is 60 point, so x2 equals 60.8. Is it feasible? Is it right? We know x2, this side of the mu. The mu is 50. So x2 definitely greater than 50. Yeah? Yeah, that is the answer we got. So 60.8. So this is 60.8, this is 40. In between 40 and 60.8, 70% of the percentage of the data will lie between the two values. The next one, I'm going to go for another subtopic. Before, I just wanted to take a little break and then see we could start with that. The next topic will be the approximation of binomial distribution. Or let me go through what is binomial distribution and then how to approximate from the binomial distribution to the normal distribution. Let me come back to you. Just have a little break.